I'm bringing you in for a very close shot because you need to see the detail on this bridge. This was not a factory-made CNC bridge. This is a one-off bridge that somebody actually did all of this machining for this guy in Argentina, or maybe he did the machining himself, I don't know. The tip of this fastener was actually turned down so it would grab the ball end of the string. So the ball end of the string just slips into that cuff. Yeah, I did find that a little tight, so I have a drill bit. I'm drilling this out slightly oversized. Be right back. It's a 3/16 inch. Okay, here's the next step. I've taken the length of that down. Now I'll shape it to a point. Okay, so now we're back with the larger fastener. So there's two reasons I changed to this. For universality, so that for removing the strings on both ends, we now have the same fasteners. Again, these small ones, there's nothing wrong with them. I'm just worried about Colin as he's bopping around from Montreal to New York to Toronto doing his gigs. I can just envision him dropping one of these things and it rolling off into a shag rug or something. So the larger one, and I'll make a couple of spares for him, will be a lot easier to keep track of. But I had to show you that because you really have to appreciate how much work went into designing this bridge from the ground up. I am uber impressed with this guy. I've had to re-engineer, and there's all kinds of little niggling things that need to be addressed, but once it's done, this will be super stable. Okay, so one more of these and we're done. Okay, we've drilled that out. That ball end fits in effortlessly now, and we've got our replacement fastener. And we've got our hand-machined, knurled fine tuner adjuster. You can see the knurling on each of these is slightly different. No, I'm not sponsored by him, never met the guy, but gotta tell you, I'm impressed. So before we go any further with this, before I tighten up that last string and set that up, I want to pull this off because you really have to have a good look at this to appreciate the amount of work that went into this design. Okay, obviously you have a block here. You got 3 possible indexing holes. Now that single fastener allows the saddles to pivot. You can see that I have pivoted them all uniformly to get the strings to line up with the neck. Just one more part of this design that this guy has really allowed for all kinds of forgiveness. So I'm going to bring this over to the bench. Okay, so let's have a look at this whole thing in its entirety. First of all, we have a solid brass that he's drilled and tapped. So the fine adjuster is solid brass. It's drilled through and tapped and knurled, flat on one side, domed on the other side. And that allows you to tension the string, as you saw earlier. I have kept all of these original set screws that he turned ever so minutely to index into the ball end of the string and to allow this tuner to work. These same set screws were used on the headstock. I did swap those out too, and we'll get to that in a minute. There is your retention fastener that goes into the solid brass block and allows this whole thing to slide forward or backward to set up your intonation. On this end, he drilled and tapped for this set screw. And in this case, it's worked in our favor because we have the lower portion of that slot in the top receives the string as it leaves the tuner. and the higher portion sets your intonation. He's drilled and tapped that cylinder as well. And that's how you adjust your action or your height of each individual string. See, he started with solid brass. So he bored a blind hole here. He bored this hole and threaded it to catch that cylinder. He bored the actual cylinder and threaded that and slotted the top end. And then he milled out the brass stock and slotted it so that that fastener, hope you're following me here, so that that fastener could be fastened into that solid brass block, which is the base plate for the bridge. Now, it's worked in our favor because the strings didn't quite line up with the outside of the fingerboard. So, as you saw earlier, I needed to pivot all 6 saddles to get the strings to line up with the outside of the fingerboard. And then lastly, you saw I switched the small fasteners with these larger ones and turned them on my disc sander on the drill press to get a point that would index into the ball end of the string. That's it. Oh yeah, obviously this was slotted and a hole bored through the end. And he left enough meat on the end so that the tuner could butt up against that without the whole thing collapsing. I had a guy that made a comment. I ended up just deleting it. He was kind of grandstanding and trying to pick this guitar apart, but you know, you have to understand that this guy is in Argentina. He probably has next to no resources, certainly nothing compared to what we have here in North America or Europe for that matter. So I still stand by my conviction that this design took a lot of ingenuity and a tremendous amount of machining to make this a reality. So I'm more than happy to overlook all the sort of irritations for a couple of reasons. One is Colin is a long-time friend and customer, and the other thing is I'm willing to take this the rest of the way to the finish line just out of respect for all the work that this guy's put into not just the design, but the execution of the machining. So there you go. That's what we got. We're not done yet. There was a bit of re-engineering at the other end, and we'll talk about that in a minute. So now we're dealing with this end of the scale. So there are several things that I needed to address. The nut itself was not sitting in tight against the fingerboard. That was one thing. All he had as retainers was 2 little wood screws. It wasn't enough to withstand the string tension, which was tilting the whole thing up. So we had to remedy that. I did change over to the larger fastener, so with 1 Allen key, Colin can install the strings and tune the strings. So this whole block of brass now is sitting nice and tight. The other thing was, on the underside, I drilled and tapped, and as you can see, there wasn't a lot of wiggle room there. I drilled and tapped those 2 holes. I'll flip it over and show you in a minute, but I bored the underside, and this allowed us to bolt this down tightly. No more tipping. Well, as you can see, I bored and countersunk those holes. I've got a washer and a lock washer. So now I can bolt that whole assembly down and hold it flush and tight up against the end of the fingerboard. So as you can see, there was not a lot of room for error here. We skirted either side of that truss rod, and now that whole locking nut assembly, you can see that there was not a lot of forgiveness. From the center of that truss rod and these 2 fasteners, they just skirted the outside of the truss rod. And now we'll concentrate on the compensated nut. Well, after a full week of tweaking and re-engineering, this is what we ended up with. So that brass piece just ahead of the original nut has been calibrated for 10 to 46 strings of concert pitch for this scale length. This is what I referred to earlier in the video where I canted those saddles to get the strings to line up with the pickups and the outside of the fingerboard. So I ended up pivoting all of those saddles towards the bass side to get the strings to line up with the pickups and the edge of the fingerboard. So it really is a pretty unique and striking instrument, super comfortable to play. I'll play it in a second and let you hear it. And this is the view from the back side, and as you can see there are 3 potential places for leg rest. It is actually very comfortable to play. So you can orient the guitar to any one of those 3 leg rests. And these are the threaded fasteners that hold that big chunk of brass in place. This is the short progression that I looped. So let that play, and I'm going to just do tenths. Okay, so here's another lick that I kind of looped and I'll play over top of.